This is section 5-10, multiplying polynomials, monomials and polynomials. You're doing page 247, number 1 through 44, odd in the green book. Some information some vocabulary that I want you to know for this is monomial, polynomial, binomial, trinomial, FOIL, which represents first, outside, inside, last, and double distributing. They basically mean, the last two mean the same thing. Okay. So when we multiply polynomials, if I multiply a monomial by a polynomial, it looks something like this. Monomial means one term by more than one term. So here's the monomial 3, and here's a polynomial. What kind of polynomial? It's a binomial. So when I'm multiplying like this, a monomial by a binomial, we get 3 times x is 3x, and 3 times 4 is positive 12. And that is as simplified as it can get. We cannot figure out what x is. Do not even try. There is no way to. So this is a simplified polynomial. I'd like you to, I'll try the next one with you, and you're going to do 2a times a is 2a squared, and 2a times negative 5 is negative 10a. Now pause the recording and you try number 3. Now check your work. You get 6k. Now 2 times 6 is 12. I've got k to the first and k to the second. That makes k to the third. Remember when we're multiplying exponents we just really add the common bases. 6k to the first times positive 4k makes positive 24k to the second, sorry. And then we've got 6k to the first times negative 3 makes negative 18, and k to the first. There you go. Kind of putting together what we learned earlier in the chapter. All right, it's just really the distributive property. Now, multiplying polynomials, we have a couple different ways you can do them. Before you know it, you're going to start doing this in your head. But the horizontal method is just like double distributing. I don't even like to show them that way. I just take the first one and I'm going to distribute it. That becomes 2x to the third, squared, sorry. It's x to the first and x to the first, so it's 2x squared. And then when I distribute over here, I get minus 3x. And then I've got 5 times 2x makes 10x plus 10x. And 5 times negative 3 is negative 15. And now I can combine my like terms. So I've got 2x squared. I'm going to combine these two. Minus 7x minus 15. So that's the first way. It's just double distributing. Distribute the x to everything in the second one. Distribute the 5. And then you combine like terms and put it as simple as possible. They're kind of doing it backwards in this video. Okay, a vertical method is when you list both binomials, and we're going to multiply just like we would multiply a double-digit number. So I do negative 3 times 5 is negative 15, and negative 3 times x is negative 3x. Now I'm going to try multiplying 2x by everything on the first line. Positive 2x times 5 is negative 10x. So I'm going to put it right underneath the x term. And 2x times x is 2x squared. 2x squared minus 13x minus 15 is my final answer. Wait a second, what did I do wrong here? Negative 3. Negative 3 times x is negative 3x. Yep. Oh, I see. It should have been positive 10x. So that really makes 7x. Here we go. Because it's the same binomial. I figured that out. Okay, sorry about that. Lost a negative there. I mean, lost a positive there. So it should be plus 7x. Positive 7x. Because I'm multiplying positive 2x times positive 5 makes positive 10x. Subtract 3x makes 7x. All right. So here we go. Multiplying polynomials. When we have, I want you to try this one, okay? Pause the recording, see what you get. Okay, now let's check it. I bet that many people got this. But this is not the case because x plus 3, the quantity of x plus 3 squared really equals this. People want to distribute that exponent, and that is actually the wrong thing to do. We don't distribute exponents over a plus sign. If there's more than, in a term, if there's more than one letter, each letter gets the square, but not over a plus sign. What this means is the binomial is squared. I have to do x plus 3 times x plus 3, the quantity of x plus 3 times the quantity. And then we're going to have to do that double distributing again, okay? So we're doing x times x is x squared plus 3x, and then I'm getting another plus 3x, and then I'm going to get another plus 9. So that really equals x squared plus 6x plus 9. Okay, so be careful. We do not distribute that exponent in a binomial. It's different when you have like 5xy to the third z to the fourth, and that whole thing is being squared. In that case, when you square everything, notice there's no plus sign in there. So whenever you have a binomial, we cannot distribute the squared. Got it? And so now we are doing, you can do it vertical. I think vertical takes a little bit too much time. Pretty soon you're going to be able to do these in your head after we start factoring. All right, so pause the recording and let's try. You want me to do the first one? What if I do the first one? Remember, this means 2x plus 5 times 2x plus 5, and that makes 4x squared, right? And that makes plus 10x. Now notice, I'm going to just put it right in the same column. Plus 10x, and that's plus 25, so that's 4x squared plus 20x plus 25. Pause the recording and try yours. Number 2. Now check your work. You should have 9x squared minus 24x plus 16. All right, so in many algebra classes, you'll hear the term FOIL. FOIL is basically double distributing. I want you to know it. A lot of teachers don't like it. Newer teachers don't like it. When I was in high school, we used FOIL. And they don't like it for a good reason. It limits you to multiplying binomial by binomial. It doesn't work if you're doing a binomial times a trinomial or a trinomial times trinomial. So FOIL is limiting. So usually we like to say distributing. So what it stands for is, so most of the time when you multiply a binomial times a binomial, you will get a trinomial. There are some exceptions. So what it represents is the first terms. They're going to do it this way. I don't like to do it like this. Okay, let's first go back and discuss. Now, when you multiply a binomial times a binomial, you need to write this down. You will get, okay, when I'm doing that, x times x, we get a quadratic term, x squared. When I'm doing this, I get negative 5x. And when I do this, I get plus 3x. That makes 2x, negative 2x. And that's right here. We call that, when x is to the first power, it is the linear term. When x is squared, it is the quadratic term. And then we're going to do the rest of it. 3 times negative 5 is negative 15. We get the constant term. Okay? We get the constant term. So, this takes too long. I'm going to show you a little shortcut. Well, first we'll learn to FOIL. Then I'll tell you the memorization technique. FOIL means we multiply the first term in each, right? This is our first. So that would be x squared. We multiply the outside, which are these two. So that would be negative 5x. We multiply the inside, which would be plus 3x. And we multiply the last terms. 3 times 5, which is 15. Does that make sense? First, outside, inside, last. So just make sure that you get all of the first terms, again, are the x times x. We get x squared. The last are the 3 times negative 5. The outside, or the outer side of both binomials, the farthest two, and the inside are the two that are touching. So the first multiply to x squared. The outer make negative 5x. The inner make plus 3x. And the last make negative 15. Simplify, we get x squared minus 2x minus 15. Okay? So try it, foiling. Remember, first, outside, inside, last. Pause the recording and you try it. Check your work. And that makes 9m in the middle. So, I'm going to show you a fast way. Well, we know that if we have a y and a y, it's always going to be a y squared. And the last is always here. We multiply the two, 28. And the middle term, we add the two together, right? Let me go back. Let's go back over here. Okay, so we know that this is what it equals. I'm going to show you. So if I see m and m, I know it's going to be an m squared. To get the last term, right, we have to multiply the last two. That makes positive 18. To get the inner term, we have to add the numbers, the two last numbers. Okay, what is 6 and 3? Is 9. And remember, a linear term, the middle term, always has an m to the first power. So we use the letter, it goes here, m squared. We add the two last numbers, and they become the coefficient of the linear term, m to the first power. We multiply the last two terms, and they become the constant term. So let's try it. Okay. So these should go really quick here on this page where you saw all these problems. Really, okay, so let's start. So we know it's going to be y squared. When I add the two last terms, I get positive 11y, right? We got to add the y because it's going to end up being 7y, and then when I multiply the last two terms, I get positive 28. Next one's going to be m squared. Add the two inner term, the two terms, two constants would be 10m. Always have to leave that linear term, m to the first power, and then multiply it, it's plus 16. Okay, pause the recording and finish them up. Now check your work. It should be x squared, positive 6 and negative 4 make plus 2x. Positive 6 times negative 4 is negative 24. I get t squared, it's minus 4t and minus 60. Next one is x squared minus 9x plus 20. Negative 4 times negative 5 is 20. Negative 4 times negative 4 plus negative 5 make negative 9x. Okay, the next one, x squared. And I'm going to do, remember, I'm adding 3 minus 11 is negative 5. It's a middle term, right? So it's got to have that x. And then the last term is negative 24. Next one is y squared minus 16y plus 63. X squared minus 9x plus minus 22. Next one, keep it in order. So 2 times 7 is 14. When I add them, it's going to be 7 minus 2 is minus plus 5m. And then I'm going to have a negative and a positive multiplied together, make a negative m squared. Keep it in that order. Don't put it in a descending order. Keep it in the order it was given. So again, I'm going to get 24. We know the last one will be k squared and it's positive. And this will be, we've got negative 6k, negative 4k, that makes negative 10k. There we go. All right, let's try the next page. More of the same. Okay, these get a little bit more complicated, so let's practice a couple of them because they have some coefficients. These, I can't do it so quickly. I usually like to FOIL or double distribute. So here I have a 2x squared, and I've got my outside, which is plus 12x, and then I've got my inside, which is plus 3x, and then plus 18, my last. Simplifies to 2x squared plus 15x plus 18. Does that make sense? So you're just double distributing. I don't know what's happening. Double distributing 2x squared plus, next one's going to be 2k squared, and I'm going to have plus 35, and then the middle term will be negative 10k, and negative 7k make negative 17k. Pause the recording and try the rest on your own. Now check your work. 13 is 2m squared plus 7m minus 30. 3x squared minus 17x minus 28. 2x squared minus 21x plus 54. X to the fourth plus 4x squared minus 45. Number 17 is 6x cubed plus 3x squared plus 6k plus 3. So we said most of the time you're going to get a trinomial. This is one of those exceptions. Let's look at the next one too. I'm going to kind of enlarge it. Look what happens. We get m squared, right? And then notice my outside is going to be negative 5m. My inside will be positive 5m. And my last will be negative 25. And this is what we call, well, when we're factoring, it's going to be, we'll see the result, okay? So what happens when I have negative 5m and positive 5n, they negate each other. We're left with m squared minus 25. So whenever you have a polynomial, right, and they're exactly the same, but one is plus and the other is minus, you're going to end up with a binomial, another one of those exceptions. Square the first term, square the last term, the middle term disappears. So square the first term would be 16t squared. Square the last one is 49, and notice it has a minus sign in the middle. And that's because you're going to get positive 28t and negative 28t. So with that in mind, you lose that middle term. You only have the first and the last term. Try the last one, and your answer is 2mx. Two different variables. Don't freak out. Don't freak out. 2x times m. Whoops. I lost it. Sorry. The last one you get, 2x times m makes 2xm. 2x times negative 5 is negative 5 times 2 is negative 10x. And then I've got 3 times m is plus 3m. And then 3 times negative 5 is negative 15. There's no like terms, so we end up. So this one, this one, this one, and this one are all kind of exceptions. So, and when we get our m squared minus 25, we call this a difference of squares because it's a perfect square minus a perfect square. And that happens, you get a binomial when you have two binomials that are being multiplied by each other, where one is positive and the other is negative. And that's the lesson.